We are studying the second chapter, Numbers and Sequences. The exercise is 2.6. The first 6 sums of this exercise 2.6 I've done in the previous video. You can go through that. We are going to start with sum number 7. Find the sum of all natural numbers between 602 and 902 which are not divisible by 4. In this sum, what we are going to do is, first we are going to find the sum of all natural numbers between these two numbers. Okay, then we are going to find the sum of all natural numbers between these two numbers which are divisible by 4, and then we are going to subtract the numbers which are divisible, the sum of numbers which are divisible by 4 from the total. That will give us the sum of numbers not divisible by 4. Okay, very simple. Let's go to the sum. First, we will find the sum of all natural numbers between 602 and 902. They are saying between these two numbers. So, we should not consider these two numbers. Okay, so what is the first number here? The first term will be 603. After 602, the next number will be 603. Okay, and we are going to consider all natural numbers. So, the difference between any two terms, the next number will be 604. So, 604 minus 603 is 1. So, the common difference is 1. Okay, the last number will be 901. We will not consider 902. Okay, 901 is the last term. Now, the number of terms in this arithmetic progression. This is an arithmetic progression. First, let's find out the number of terms. Use this formula for arithmetic progression. You will get the number of terms as 299. Now, the sum of all these terms will be given by Sn is equal to n upon 2 a plus l. Substitute these values of a and l and you will get, this is the number, 2,24,848. This is the sum of all natural numbers between 602 and 902. Next, we are going to find the sum of all natural numbers between this which are divisible by 4. Okay, so which are divisible by 4. For that, the first term will be 602, we should not consider. 603 is not divisible by 4. 604 is divisible by 4. So, the first term will be 604. And then we will have many terms. After that, the last term will be 902, we should not consider. 901 is not divisible by 4. So, 900 is divisible by 4. So, the last term is 900. Okay. So, the terms are from, it will start from 604 and end with 900. And the next term after this will be only 608, which will be divisible by 4. So, the common difference is 608 minus 604, that is 4. Okay. Now, let us find out the number of terms which are divisible by 4. For that, use this and find the terms. That is only 75 terms we can have in between these two numbers. Okay. The sum of all these terms, again use these values, substitute, and you will get the sum of these terms which are divisible by 4 is 56,400. Okay, the question is we have to find the sum of terms which are not divisible by 4. So, what we are going to do? Total minus the terms sum divisible by 4. So, 2,24,848 minus 56,400 will give us 1,68,448. This is the answer. Question 8. Raghu wishes to buy a laptop. He can buy it by paying 40,000 cash or by giving it in 10 installments as 4,800 in the first month, 4,750 in the second month, 4,700 in the third month, and so on. If he pays the money in this fashion, find the total amount paid in 10 installments and how much extra amount that he has to pay than the cost. Okay. So, here this is an arithmetic progression. The first month is the first term. He is paying 4,800. Second month, 50 rupees less. So, it is 4,750. Okay. Third month this much. So 10 months he is going to pay like this. Every month 50 rupees less. So total how much money he is going to pay for this laptop? That is the question. So let's write down first term. The first month is 4,800. Common difference. This second term minus the first term, it is minus 50. D is minus 50. N total terms, the total months, that is 10. Okay, use this formula. Sn is equal to n upon 2, 2a plus n minus 1d, and substitute the values, you will get this. So the sum of the amounts he has paid for the 10 months will be 45,750. Total amount paid in 10 installments, 45,750. Extra amount he pays, this is the cost, and this minus 40,000 will be 5,750. A man repays the loan of 65,000 by paying rupees 400 in the first month and then increasing the payment by rupees 300 every month. How long will it take for him to clear the loan? So the total amount he is going to pay to clear the loan is 65,000. That is SN, the total 65,000. First month how much he pays? 400. And increase in every month. Every month is going to increase by 300. That is the common difference. Okay, write down the formula. Substitute these values. Simplify. It is a quadratic equation. The number of terms n. Okay. So here you can split the middle term. This requires algebra. Okay. And here it is. You get the value of n as 20 or minus 65 by 3. It cannot, n can never be negative, and that too a fraction. So the n is equal to 20 is the right answer. Months taken to repay the loan is 20 months. A brick staircase has a total of 30 steps. The bottom step requires 100 bricks. Each successive step requires 2 bricks less than the previous step. How many bricks are required for the topmost step? How many bricks are required to build the staircase? So the bottom step has got 100 bricks. The next above it, 2 bricks less, 98, then 96, 94, so forth. And there are 30 steps. So total bricks required will be the sum of all this. Let us find it. This is the first term. This is an arithmetic progression. First term is 100. Common difference is 98 minus 100. Second term minus first term. So that is minus 2. N, the number of steps is 30. Use this formula. Substitute these values and you will get the total number of bricks required for 30 steps is 2130. Now, how many bricks are required for the topmost step? That means the number of bricks on the 30th step. T30. Okay, that is a minus n minus 1d. This is the formula for nth term of a arithmetic progression, and this sum is an arithmetic progression. So let us substitute these values. You will get the 30th step. The number of bricks in the 30th step will be 42. Okay, question 11. If S1, S2, S3, Sm are the sums of n terms of APs whose first terms are 1, 2, 3, m and whose common differences are 1, 3, 5, 2m minus 1 respectively, then show that S1 plus S2 plus S3 Sm is equal to 1 upon 2 mn into mn plus 1. So in this sum, what we are going to do is, first we are going to write down what is S1, S2, S3, Sm, and then we are going to add it up so that we will get the LHS. So S1 plus S2 is equal to this way. Then we will show that LHS is equal to RHS. So first let us write down what is S1. Okay. Now S1, S2, S3, Sm are the sums of n terms of APs whose first term. So S1's first term is 1 and the common difference is 1. That is the meaning. S2, the first term is 2. The common difference is 3. S3, the first term is 3. Common difference is 5. Okay, so let's write down S1. Okay, the general formula you know for Sn is n upon 2 into a plus n minus 1 d. Okay, for S1, so here the first term a is 1 and the common difference is 1. So substitute, you get n upon 2 n plus 1. Okay, that is S1. Similarly, we are going to find out S2, S3, Sm, and then we are going to add up. S2, the first term is 2, common difference is 3. So put in the formula, you get this n upon 2, 3n plus 1. S3, you will get n upon 2, 5n plus 1. Sm, the first term is m, common difference is 2m minus 1. Substitute in the formula, simplify it. Here it is. You open this brackets, you will get like this. And here I have taken out n common, so 2m minus 1 plus 1. So here it is. This is Sm. Now for LHS, I'm going to add up everything. S1 plus S2 plus S3 plus Sm. So here it is. N upon 2 is common and rest you can put it in a bracket like this. You simplify it, you will get like this. Okay. Now here from these terms you can take out n common. So n into 1 plus 3 plus 5 dot 2m minus 1. Now this is again an arithmetic progression. Okay. This is the first term, last term, the common difference is 2. So here let's write down first term and last term. You don't need the common difference. The number of terms, okay, is m in this sum. So you can substitute these values, you will get m square. So this will be, you can substitute m square for that arithmetic progression. So you will get n into m square plus m like this. Okay, open the bracket, you will get like this. So here you can take out m common. So 1 upon 2 mn into mn plus 1. So this is the RHS. LHS is equal to RHS. Find the sum. So this is a arithmetic progression, okay, up to 12 terms. So first term is A, the second term is common differences, second term minus the first term. So write down 3a minus 2b upon a plus b minus a minus b upon a plus b. A plus b is the LCM. So write down the LCM. 3a minus a is 2a. Minus 2b plus, minus into minus is plus. So minus 2b plus b is minus b. So you get this numerator and denominator. This is d. So write down the formula for Sn and substitute a as a minus b upon a plus b and d as 2a minus b upon a plus b. Again here a plus b is the LCM. 12 upon 2 is 6. A plus b is the LCM, write it. Open the bracket, 2a minus 2b plus 12 minus 1 is 11. 11 into 2 is 22a minus 11b. Okay, that's it. Now you can simplify this further. It's 24a minus 13b upon a plus b into 6. So this is the answer. Here we come to the end of the exercise. Please go through the exercise once more. The previous 1 to 6 sums of the exercise I've done in a previous video. You can go through that also.